Hi everyone, welcome back to the channel. Now this is a simple problem and it has been there for a long time. In fact, many different variations of this problem has been asked in different examinations, and yet students fail to solve this problem completely. In fact, the postgrads also make mistakes. Why does this happen? Now let's look at the problem closely. There is a uniform circular hoop of mass m which is placed on a horizontal table, and there is no friction between hoop and the table, so hoop can move freely on the table. There is a bug of mass m which can run on the hoop, and at time t equal to 0 it starts running, let's say with velocity v, which is constant. Now the question is, what is the angle turned through by the hoop when the bug completes one lap? So when bug returns to the same point, what do you think the angle turned through by the hoop? Now the problem seems very simple because we think that there is no external force, hence the angular momentum must be conserved, and we get the omega, and then we figure out the angle that the hoop should turn through when the bug returns to the same point. But let's see what's going on. When we see the hoop, and this is the center, and the bug is here. Let's say this is mass m and hoop is of mass n. We wrongly think that the center of mass of this entire system is at the center of the hoop, O. And that is not the case because center of mass has shifted somewhere towards this point. Let's say this is C. And then the hoop will start rotating around this point and not this point. Because since there is no external force, so the movement of center of mass will be 0. So if external force is 0, that means that center of mass is at rest. And this is the most important concept here. Rest everything is very simple. So now let's compute the center of mass. Let's say this distance is x, OC, and let's say that the radius of this hoop is r. Therefore, this distance will be r minus x. So we can compute the CM, which is x as m into 0 plus m into r divided by m plus m, which is m by m plus m r. And also, therefore, we can also say that r minus x is simply m by m plus m and r. And if this is there, then it's very simple to write the equation from the conservation of angular momentum. So angular momentum is conserved, which means that if this is the bug is moving with velocity u, then mu r minus x, which is at this point C, should be equal to I omega. Now what is I here? So I is nothing but m r square for the hoop plus m x square and plus m r minus x. Therefore, this is mr square plus m x is nothing but this, so m by m plus m whole square r square, and r minus x is here, so m by m plus m r square. So we can take mr common, so therefore it is m1 plus m square plus m plus m whole square plus mm m plus m whole square, and therefore mr square, this is this will become m plus m and m plus 2m by m plus m. Therefore, this will be m plus 2m by m plus m r square. And if we put this here in this equation, then we will have m u, we can replace r minus x with m by m plus m r, and then m plus 2m by m plus m r square. So here we'll get, and then omega, therefore we'll get omega as m by m plus 2m u by. Therefore, the time taken by the bug to complete one lap will be 2 pi r by u, and that should also be equal to the time taken by the hook, which will be theta by omega, and that means theta is 2m by m plus 2m pi. Hence, if m is m by 2, that implies theta will be pi by 2. So A is the right answer. Now let's hinge this hoop at the center so that it is forced to rotate only through O. Now in this case, it will be very simple to write the equation, because it will become MUR equal to I, which is MR square plus MR square, let's say omega prime, and in this case the omega prime is M by M plus M U by R. Now if you compare this with this omega, you see that omega prime is greater than omega. So the question is, why is this? Why omega prime is greater than omega? Why the angular speed of hoop is larger or greater when it is hinged at the center than the case where it is free to rotate through its center of mass? Think about it and let me know in the comments. You can also send me emails. And if you think this has helped you in some way, then please do like the video. Do subscribe the channel, because I keep posting such problems every week. Thank you very much.